but we're going to just, anyway, start with equivalent fractions with a number line because we've been doing number lines this year. And number lines are one way to show equivalent fractions. And so I'll record this and then give you a small homework assignment. And based off of that, the way fractions are at the elementary school, there'll be times where I split you guys into small groups. And some of you will move ahead at a different pace than the others. And that's going to be different groups all the time. Okay? So just to keep you kind of making progress at your best rate. So if this were a number line, and this were 0, and this were 1, if we counted the jumps here, there are, let's count the jumps here. There's 1, 2, 3, 4, 5, 6, 7, 8 jumps. Okay, so Oliver, what's the first fraction here then?
1/8.
1/8, right? And so if we just did eighths, we could go across and write 2/8 and 3/8 all the way down till we get to 1 whole. So that's what I'm doing. But I could also take different size jumps. And if I took a different size jump, I could still, with this different size jump, start at 0 and end exactly at 1, but not do this size jump. Does anybody have an idea of another size jump? Yeah, Bryn? 4? Go 4? Like that?
No, like 4 would be 2.
Like a fourth. Okay, so 2. Jump of 2 little black jumps. So if we look at that, I can look at what Bryn said, and with that size jump, I start at 0 and I land exactly at 1. Okay? So what size jumps are those, Bryn? Instead of eighths. They're fourths, right? Because there's 4 of them. So this is a fourth up here. That would be right here. And this is 2/4. And this is 3/4. And this is 4/4, 1 whole. It's also 8/8. Okay. So what's the other size jump I can do? Jeff, do you have a question or you have another jump?
And also like question comment thing.
Well, if the number of jumps, no matter what, whatever like that half of that number is. So if it was 6, 3 could go into it. If it was
right. So your jumps have to be, in this case, the size of the jump has to be divisible, has to be a factor of 8. So we know that 4 is a factor of 8, and 8 is a factor of 8. What's another one, Wes?
half.
I could do halves, right? So that would be the other size jumps. So there's 2 jumps there. So another way to write this fraction right here, let's see, would be a half. Okay, I'm going to pause this because of the... Okay, so the reason I did the number line is the number line can show you some nice sets of equivalent fractions with something we've already done before. So Tanner, give me an example of equivalent fractions up there. Right, so 4/8 could be 1/2 or 2/4. Okay, Augie, what's another one?
You could do 2/8, 4/8, and 6/8.
Those aren't equivalent. Why'd you put the book away? Emily? Yeah, 1/4 and 2/8. Augie? 3/4 and 6/8. Okay. And yeah, what's the other one, Jeff?
4/4.
Yeah, 4/4 and 8/8 are also equivalent fractions. Okay. So my sense is that when I looked at the diagnostic, most everybody can do an equivalent fraction, but not everybody could come up with multiple equivalent fractions. So let's just go through a system today of how to do that. And I'm going to ask you guys to write down a few notes. And let's take a look at the notes that I'm going to have you write down. So we're going to use this idea of equivalent fractions. And we're going to look at the book wording, the way they ask you to do some problems tonight, and just go through some samples with something called the ratio table. Okay, so if you guys could take out some note paper, I'll make this larger, and we can start with some notes on this. Okay, so let's go ahead and take out a note paper and write a couple examples down. I'm going to pause this and give you a little bit of time to write down some examples. Just again, okay, I'm going to just use a table here. I'm just going to start that again. I didn't start it. What I noticed is on your diagnostic, you didn't all know how to reduce fractions down, but a lot of you knew how to build them up. So if I'm going to ask you to write two equivalent fractions, like the book does here, then we're going to actually practice doing more than two, okay? Just to see that you can get bunches and bunches of equivalent fractions. But take your first fraction, like 3/6 here, and think of what we did the last couple weeks with GCFs and the greatest common factors. We were always looking for common factors. So Tanner, what's a common factor to 3 and 6? What number goes into both? No, not what do they both go into, but what goes into them. What number do they both have in common? 3. Does that make sense? So whenever you're writing equivalent fractions, if you can, first look and see if you can reduce it down. Sometimes you can, sometimes you can't. But if you can divide both of these by 3, both the 3 and the 6. And so if I divide 3 by 3, I get a 1. And if I divide 6 by 3, I get a 2, okay? So I could also build them up. But right now, if I had to write two fractions that are equivalent to the first fraction, I've already got 1/2 as one of my answers. Okay? I could build them up. I could multiply. Yes?
You could do 2/4.
Right, I could double. And so up here, I could multiply this by 2, and I could multiply this by 2. So I could do 2/4. Okay? There's lots of things you can do. You could have tripled something. You could have tripled the first one if you wanted. That would be an equivalent fraction. I could multiply this by 3, and I would get 9, but then I would have to triple the bottom one. So as long as I'm doing the same thing to the numerator, which is the top part of the fraction, and the denominator, I'm getting equivalent fractions. That's all I have to do. So Maya, for example, if I wanted to get another equivalent fraction right here, I could multiply this by 10. Practice multiplying by 10. And I would get another equivalent fraction. What's 9 times 10? 90, right? So, and then 18 times 10 is 180. So, if this is the first fraction, 3/6, all of these are equal fractions. They are all the same because the top number is half the bottom number. That makes them equivalent, okay? In this problem. So one of the things you have to do for homework today is take a fraction like 12/18 and write equivalent fractions. So let's do the same thing for 12/18. Okay, so on your sheet of paper, take the 12/18 and make some equivalent fractions. But the first thing I want you to do is reduce it down a little bit, as much as you can, maybe, and then try to build it up. And do that on your own paper, and then we'll compare answers. Okay, if we're going to start with 12/18, Wes, it sounds like you kind of have the idea. Can you divide that to make it smaller, reduce it down?
Yeah, I said just
Divided by 2.
Okay, so one thing you could do is divide by 2. That would work. So if you divide the numerator by 2, divide the denominator by 2. So the word numerator, you guys, is the top part of the fraction, and denominator is the bottom part. So what's 12 divided by 2, Wes?
6.
6. And then 18 divided by 2 is
Okay.
9. So we have one fraction now that's equivalent to 12/18. It's 6/9. That's one. You only need to get 2 for your homework, but let's get a few more for the notes. Okay, Bryce.
6
Yeah, so you could triple these if you wanted. Times by 3. You could triple them. So 6 times 3 is 18. 9 times 3 is 27. You could go to the 6/9 here, go back here, and reduce it more. What goes into both 6 and 9?
3.
Yeah, so you would do what?
3.
What about, what would you do with the 3, Zoe?
For the top. Okay.
So if I want to reduce it, would I divide by the 3 or multiply?
I would divide.
Right, you would divide by 3. And for the numerator, what would you get when you divide 6 by 3?
2.
2. And then in the denominator, Emily? 3. So that's the most reduced you could get. So some answers are 6/9, 18/27, 2/3. There's a lot of answers that you can make. 18/27. All of these answers here are equivalent fractions. You could make more. You could always, Kayla, can you make one by multiplying something by 10? Like you could, what if you multiply this by 10? That would make another set of equivalent fractions. What would you get? Oh, yeah, you could multiply this by 10, too. Let's do that. That one works. Instead, 120 over 1. 180. But, Tanner, what was I thinking she was going to say? Do you think? If I multiply this by 10. 20 over 30. So all of those are the same. They're all equivalent fractions. Okay? Just raise your hand if you get that. How are we doing, Leslie? Do you understand that? So maybe after I go through the next set of examples, have a little time, I'll practice with you. Okay? We're going to go to the next set, and then I'll let some of you guys get started and practice with another group. Jeff, question?
Oh, no.
You got it. Okay. So the reason I like this method is if you use this method, you can do the same thing when you're asked to simplify. You're asked to simplify, you're just going to get the most reduced one. You're going to reduce it all the way down. So you're going to divide out every single thing you can. So if I want to do that, you probably are going to use a little bit smaller table, but maybe not. So let's bring a table over here and use that same strategy. So Emily, can you help me simplify 16/20ths? What goes into both? You could divide by 4. Sure. So because 4 is a factor of 16, there's that vocabulary again using the word factor. And 4 is a factor of 20, you can divide them both by 4. So when you do that, Sophia, what do you get? 16 divided by 4 is?
Divided by 4 is 4.
Right, and then 20 divided by 4 is?
5. You know. Yeah,
5. We'll get you on the next one, Ben. Okay, so then when you look at 4/5, is there anything other than 1 common to both?
5.
No. So that's the most simplified answer. So this simplified fraction is 4/5. Hang on, guys. Okay, so for 24 over 36, it might take more steps for some of you. It might take less steps. Okay, but For 24 over 36, some of you can do it in a step. Some of you might take 2 steps or 3 steps. So let's suppose you know a common factor, but you maybe don't know the biggest common factor of 24 and 36. Question, Emily, or just you're going to start the problem? Do you have the answer already? Well, no, let me just, sorry. Define it. Say that a little louder. Okay, what can you divide by? You could divide by 6, because 6 is a factor of 24 and 36. Okay? So if you do that, hang on. So Ben, what's 24 divided by 6? Close. Count up by 6s. 6, 12, 18, 24. So 4. Okay, and Zoe, what's 36 divided by 6?
That's 6. I had a different way.
Okay, well, we're going to do it this way. Not right now. So let's start with this way, because it's good practice to start with the way that somebody else starts. Is 4, 6 simplified? Are there any factors that are in both 4 and 6? What are they?
Well, 2.
2 can go into both. So you have to keep going until there's no common factors, just like the division ladder. So when I divide by 2, what's 4 divided by 2? Yeah, Wes?
2.
2, and 6 divided by 2 is 3. So Zoe, when you did your different way, Sam, go ahead and put that in the red folder. When you did your different way, did you still get 2/3?
Yeah.
Yeah, so it's okay to do it a different way. So the goal is to go all the way down until there's no common factors, just like the division ladder. But we're working sideways, kind of. Does that make sense? Okay. So the last question that you have to do for work tonight is you have to look at the fraction they give you. So the directions are here. It says state whether each fraction is in simplest form. And so that's basically saying, look at your first problem. Is it in simplest form? Okay. If it's not, then find the simplest form. So if it's not, then you have to write it in simplest form. Okay. So you have to look at your fraction, 21 over 77, and think about that fraction, maybe turn it into a table, and see, is there any common factor between 21 and 77? So, TJ, do 21 and 77 have anything in common? What goes into 21? 3 times what? 7. Do either one of those numbers go into 77? 7. So do they have a common factor? Okay, so when we look at the original question, it says, state whether each fraction is in simplest form. So this is not in simplest form, so you would say no, it's not, because they have a common factor. You understand the directions? And then you use the common factor. So what common factor, Jackson, did you find for 21 and 77? 7. So you're going to use that common factor. And how do you think I'm going to use that, Ethan? The 7.
7 divided by.
I'm going to divide, right? I'm going to divide by 7. And then I'm going to see if, well, what's 21 divided by 7? 3. And 77 divided by 7? 11. And then I would ask the same question again. Is there a common factor between 3 and 11? No. So that's simplest form because they're both primes, right? Okay. So do number 6 on your paper and number 7, and I'll pause this. And be careful because they're not both in simplest form like some of you might think. Okay, which one's not in simplest form? Somebody I haven't heard from. Who haven't I heard from today? What about the rest of you guys? Everybody get his hands up. You just got here, that's fair. Augie, I haven't heard from you. Yeah, I have. I have. Did you answer the question? Yeah. Which one's not in simplest form? The second one. Because why?
Because 3 times 16 is 51. So 3 times 17. Yes, I'm adding this.
3 times 17. So Grace, 3 goes into both of these. Okay. We haven't heard from you today. So how am I going to use 3 to get down to what he was talking about? If I want to make this smaller, would I divide by 3 or multiply by 3? To make this smaller, you're going to divide. Okay, so 3 divided by 3 is 1, right? And then Augie, what was 51 divided by 3? 17. And 1 and 17 have nothing in common. So the simplest form is 1/17. And the answer to the first part of the question, is it in simplest form? You would first say no, it's not, and then you would get the simplest form. But this one is 3/5. It is, right? So you're just going to answer yes, and then you move to the next question. Does that make sense? Sam will get you caught up. I'm going to go ahead and stop this, but I'll work with a few of you while the rest of you, before I do that, let's get your homework set up. You're going to just set it up on note paper. And I started the first problem with the other class, but I'm going to erase it and we'll start it again. But just remember, the first one in the book is very, very straightforward. So write your assignment down and show your work in the book. Thanks, guys. For today, I'm gonna. Okay, set your homework up and let's do the first problem together. Okay, so the directions for problem 1 are the same as the directions on the left side of the page. You're just going to write 2 fractions equivalent to the given fraction. So Sam, you were taking that test. Let's have you practice with me here so you can make sure you understand this. So if I'm going to make 2 equivalent fractions, what I was telling the class was that a good habit is always to see if you could divide out a common factor and show your work. So what's a common factor of 2 and 4?
4.
Okay, that's true. 1's a common factor, but it's not going to change anything, 2. So pick a common factor other than 1. So if you divide 2 by 2, what do you get? 1. And then if you divide 4 by 2, what do you get? 2. Okay. So far we have 1 equivalent fraction would be a half. We have to come up with another one. So now you can take that half and you could multiply it by anything you want to make another equivalent fraction. 5. Okay, if you multiply by 5, what would you get? Multiply the numerator by 5 and the denominator by 5.
5 at the numerator and 10 at the denominator.
And so for problem 1, this is the original problem, 2/4, and those 2 fractions are your answers. Those are 2 equivalent fractions. Everybody might have different ones.
Can we do more than 2?
You can. I would go through and just do 2 to make sure you get through that homework without spending too much time. But then, yeah, if you want to add in 1 or 2, that's great. MJ.
So for the homework, it's just 46 and...
Right, it's 1 to 27 odd, and then just 46 and 49.
Okay.
Okay? All right, stop there.